Hi everyone, today we're looking at Module 6, Lesson 6, which is going to be on scatter plots. And our three learning targets for today say, students construct scatter plots, students use scatter plots to investigate relationships, students understand that a trend in a scatter plot does not establish a cause and effect. So the first thing we're going to do is look at an example. And what we're looking at is the quality versus price for various types of shoes. So see how the column says shoe number 1, 2, 3. Imagine those are different brands of sneakers, high tops, whatever you're thinking about. And we have here the price and the quality. So one example of this data says that a pair of sneakers that's $110 has a quality rating of 57. And we see that point on the graph where I circled it. So we want to think about when we design a scale for the axis of a scatter plot, we want to first identify the minimum and the maximum in each set of data. And that way we can find a multiple for in between those two values that's equidistant, so we can set that scale. So see how my data for price goes from a minimum of $30 to a maximum of $110, and my scale for quality goes from a minimum of 51 to a maximum of 71. That helps us to create the graph more evenly. And the question we want to think about is, do we see a pattern? And when I look at this graph, I see points all over the place. I do not see a linear pattern in the plot. That means that my points are not in the shape of a line. They're also not clustered around one particular area. So what it tells us is that cost is not necessarily a determination of quality. So depending on the cost, it's not like the most expensive shoes are the best quality. It really is random. And we can see that by looking at that data. Another example we're going to look at has to do with shoe size and reading score. And here's my graph. And it says, does shoe size affect your reading score? Now, when I look at the graph and I draw myself kind of a regression line or a line that fits that data, it seems like the larger the shoe size, the higher your reading score. So basically, if you have bigger feet, you are smarter in terms of reading. And we want to think about, does that make sense? And not really. It shouldn't matter what size your feet are when we think about how good of a reader you are. So what other outside variable could affect both the size of your shoe and your reading score? And what I'm kind of thinking of is your age. If you're older, your shoes are bigger. If you're older, you're a better reader. So sometimes we have two data points that has a trend, but they don't necessarily affect one another. This is not a cause and effect relationship. Lastly, I just want to get those learning targets down for Lesson 7. This is patterns in scatter plots. The first learning target says students can distinguish between linear and nonlinear plots. The second, students can describe positive and negative trends. And remember, that has to do with slope. And the third target says students identify or describe clusters or outliers. So when you see a lot of data in one location, or if you see a data point that's way far away from all the rest of the data.